Good morning, grade 7s. This is Mr. Ntuli. I will be here, guys, today. We will be doing geometry of 2D shapes, which is two-dimensional shapes. Our focus for today, guys, will be on triangles. Alright, I hope, guys, today, please, let us partake together. Let us ask questions when you don't understand. Let us focus on everything. Let us have our pens ready and the pencils so that we can draft whatever that we are going to learn today and take some notes that are going to help us for future purposes. Please, guys, this is going to be important for the upcoming September test, guys. Right, let me get to it without wasting time. Right, lesson outline is as follows for this area, guys. Today, the first thing that we're going to touch on is a prior knowledge. In other words, we are going to touch on what was already covered in grade 6. What did we do in grade 6? Because, guys, remember, this is a linkage. It links with everything that we have learned from grade 6. Now we are moving forward to grade 7 with it. We are not losing anything that was learned in grade 6. Then we're going to touch on what resources do we need for this part to be successful. We are going to familiarize ourselves with the vocabulary that is used and the meaning of such vocabulary. And then there will be some examples, demonstrations and examples there, guys. Some few things that we're going to touch on before we get to exercises. Then there will be exercises that we'll be doing together, guys. And I will be giving you some time to complete, and then we'll check how or where were the misconceptions or the mistakes that you guys might make somewhere, somehow. Then afterwards, I will then touch on the few tips. Remember, guys, tips, you can make your own tips after having gone through this part. And there are other tips that I have, since I've done this more, I have identified that certain things are more important to look out for before you can start answering any type of questions. So there will be those tips there for you guys to check. What is it that you must look for? What is it that you must pay careful consideration to? And how to then be able to execute it and do the activities and the questions in the tests, in the exams, or even in real life. How can you approach a certain situation where you can use your knowledge of two-dimensional shapes? Remember, guys, when we are doing all that we are doing, most this we are preparing for the life ahead. We don't know what the world might propose to us or present to us. As mathematicians, we will have to come up with a solution. And these small topics, they add up to one big problem solving, because we are expected to be problem solvers, guys. So please, let us just be together. Let us have fun in this. We can learn by having fun. We can learn by participating together. And we can learn by asking questions where there are things that we don't understand. We may write them down. Sometimes we may not be able to ask me live, but please, you may forward them to our different teachers in our schools. They will definitely be able to answer them. Right? Then let me touch on prior knowledge, guys, on things that was covered in grade 6. In grade 6, guys, we recognize, visualize, and name 2D shapes in the environment and geometric settings, focusing on regular and irregular polygons, triangles, squares, rectangles, parallelograms, other quadrilaterals, pentagons, hexagons, heptagons, octagons. So those were the things that we touched on when we were doing 2D shapes in grade 6. And then we spoke about circles. We spoke about similarities and differences between rectangles and parallelograms. Then we spoke about the characteristics of shapes, describe, sort, and compare two-dimensional shapes in terms of number of sides, length of sides, sizes of angles, acute, right, obtuse, straight, reflex, revolution. All this that I just read with you guys is what we have already covered in grade 6. So we need to now have, if we have forgotten some of the things now, it will bring to our minds that, okay, this is what we are going to talk about today, that how it links to what we are going to be doing now in grade 7. But just to give you a hint there, guys, is that in grade 7, our focus is more on triangles and quadrilaterals. Now we will revise and understand. Some of us might have forgotten what is a quadrilateral. So we'll revise such things and be familiar with them so that we can know what do those words mean, etc. going forward. Then, guys, let me touch on resources that we need to complete this session. We need to have a mathematical set, a mathematical instrument. This is what I'm talking about. So we need to have this mathematical set. It may not be like this one of mine, but it should be a mathematical set. It has got 11 pieces inside. So we need to have it. We need to have our pens ready. Obvious, guys, pencils and ruler and erasers together with a sharpener, they're already inside the mathematical instrument. And then we need to have our exercise book. Guys, I will encourage that we have a practice book. Whenever we have these sessions, just have a practice book where you will be drafting all the exercises that I'll be giving or taking some notes of the things that I'm touching on. Right, then let us get to the vocabulary and meaning that is used here. We have what we call an angular sum. There, what is an angular sum? We say angular sum is the sum of all the internal angles of a polygon. Is the sum of all the internal angles of a polygon. That is what we call angular sum. Then we have acute angled triangle. Now we will ask ourselves, what is an acute angled triangle? An acute angled triangle are triangles with all three angles acute. So for an angle to be called acute angled triangle, it means that all three angles in that triangle must be acute angles. Remember, guys, when we dealt with acute angles in grade 6, we said an acute angle is an angle from 0 to 89. Between 1 and 89 there, that angle, we normally call it an acute angle. So it means that when we say acute angled triangle, we are talking about what? We are talking about triangles with three angles acute. Meaning that in that triangle, all angles must be less than 90 degrees. Must be less than 90 degrees. And then we will talk about the vocabulary that is also used here is obtuse angled triangle. Obtuse angled triangle. Now we need to understand what is an obtuse angled triangle. An obtuse angled triangle are triangles with one obtuse angle. Are triangles with one obtuse angle. Now, guys, remember that we said an obtuse angle are all angles that are above 91, that are above 90 degrees. In other words, from 91 up to 179. It may not exceed 179. The minute it exceeds 179, it is no longer an obtuse angle. It must be from 91 degrees up to 179. Or it may be between anything above 90. It must be, first of all, an obtuse angle. It must be what? It must be above 90 degrees, but not bigger than or equal to 108. It must not be equal to 108 or bigger than 108. It means that it must be between anything above 90 up to 179 degrees. And then there is what we call right-angled triangle. A right-angled triangles are triangles with one angle equal to 90 degrees. So it means for a triangle to be called a right-angled triangle, it means that one angle must equal to 90 degrees. Then it satisfies the description of a right-angled triangle. Then we have what we call isosceles triangle. Isosceles triangle. What is an isosceles triangle, guys? All right. We say an isosceles triangle is a triangle with two equal sides and angles. In other words, for a triangle to be called an isosceles triangle, it must have two equal sides and two equal angles inside the triangle. So then it means that that triangle is called an isosceles triangle. Now, the question would be, how do we see this one is an isosceles triangle? We have to look at the markings. All triangles have markings. So those markings will give us a guide, but we will see when we get there later on, guys. And then we have what we call equilateral triangle. Equilateral triangle. What is an equilateral triangle? An equilateral triangle is a triangle with three equal sides and angles. All three sides must be equal first, and the angles inside that triangle must also be equal. Say, for example, if the length of one side is 5 centimeters, now all the three sides must be 5 centimeters. And then we have what we call a scalene triangle. What is scalene triangle? Scalene triangle is a triangle that does not have equal sides and angles. No sides are equal in a scalene. It means that one side, remember a triangle we spoke about, a polygon that has got three sides. So if it is a triangle that is called a scalene triangle, it means that no sides are equal. It means if we have got the first side being 5 centimeters, the second side might be 4 centimeters and the other side might be 7 centimeters. So it means there are no equal sides there. Then if there are no equal sides, it means that that is a scalene triangle. Right. Let us observe the following demonstrations. Looking at the following examples. There we have the first triangle, which is labeled triangle A. We have triangle B. We have triangle C. And we have triangle D. And also we have triangle E. So guys, I will give you some few minutes to just observe them and come up with the names of these triangles. What could be the name of triangle A, the name of triangle B, and triangle C, triangle D, and triangle E. So we'll give you guys 2 minutes to go through them and look at them, and you will come and tell me what are the names of these triangles. We'll try it together so that we can see what is it that we need to look out for to give the name or describe each polygon here. So your 2 minutes begin now, guys. Alright guys, I believe now our 2 minutes is up. 2 minutes is up, guys. Let us see. Let us look at these triangles, guys. Let us observe triangle A. In triangle A, guys, can we see there is a mark? There are markings there. There is one. I've seen 1, 2, and 3 markings. All 1, 1 each side. So these markings, there is a meaning behind them. In triangle B, guys, we can see there is this line, and there is this line, and there is this small square formed here. And there is a mark here, and there is also a mark here. Now, those markings also together with this formed small square here, there is a meaning behind there. And in angle C, in triangle C, there we see also there is 2 markings. We will later find out what do those markings mean. In triangle D, there is a mark on this side which is only 1 tick, and then here there is 1, 2, 3 ticks. Here there is only 2 ticks. Then this means the 3 markings on triangle D are not the same as the 3 markings on triangle A. You can you just see that, guys? Just be careful there. On triangle A, there are 1, 1, 1 markings each side. But on triangle D, on this side of the triangle, there is only 1 marking. On the base of this triangle, there are 2 markings. On this side, adjacent to this one, close to this one, there are 3 markings. And then triangle E, there are 2 markings on the side, 1 marking here, and also 3 markings on the side. So these markings, guys, they mean something. They will play a very important role when it comes to identifying the type of triangle that you are about to solve, and the calculations later on how to calculate certain unknowns. So guys, please, the most important, guys, there, these markings will give us a guide. Remember now, guys, we are in grade 7. Nothing will just sit there without having any meaning. And especially now, we are no longer saying it's a triangle. These triangles, they are all triangles. If you check the A, here has got 1, 2, 3 side, triangle. B, 1, 2, 3 side, also a triangle. C, 1, 2, 3 side, also a triangle. D, 1, 2, 3 sides, also a triangle. E, 1, 2, 3 sides, also a triangle. But somebody would ask, guys, that now say, since these triangles are all triangles, what is the difference? Because we can see the shapes, although they are having 3 sides, all of them, but the shapes are not drawn the same. This one is a normal that we are used to. This one, we normally see it. This one, yes, we see, but it is not the same as triangle A or triangle B. Triangle D is also not the same as triangle A, B, or C. And triangle E is not the same as triangle D, C, B, and A. So there is a difference. Can we see that, guys? I believe in that 2 minutes that I gave to you guys, we could see that there are differences between these triangles. That is where now we come to the names, because it means that if there are differences, it means they do not have same names because of the way they are shaped, because of the way the markings are put. So those markings will play a very important role for us to be able to identify the name of a triangle, describe the triangle, and be able to differentiate between the triangles. Let me repeat that statement, guys. These markings will play a very important role in terms of describing a triangle, differentiating a triangle, and also be able to sort if they are mixed together so that we know which one is which one. So let us get to it, guys. Triangle A, because there are only one marking. These markings in this triangle, they mean that all sides of this triangle are equal. All sides in this triangle are equal. So remember from the vocabulary there, guys, a triangle that has got all sides equal is called what? We call it an equilateral triangle. It means that all sides are equal. How do we identify that sides are equal? The markings will give us, the markings will tell us that these sides are marked and there is only one mark here, one mark here, one mark here. It means that the frequency of the marking is the same. So if there were two markings, it will also mean the same thing, because it means that these two, 1, 2, 3 sides are equal. Because why? The markings are equal. Here there's one mark which is equal to one mark here, also equal to one mark there. So it is very important that to identify the markings. Now let us get to triangle B. Triangle B, we call it a right-angled triangle. Why? Because there is a right angle there, guys. Remember when we were drawing a square, we used to, what we know about a square is that all angles inside the square are equal to 90 degrees. Now, how do we see this is equal to 90 degrees? Because we can see there is that mark there which shows a 90 degrees angle. So an angle that equals to 90 degrees, we call it a right-angled triangle. Then we have a marking here and we also a marking here. So later on we will classify this with another property. It will also be a right angle, but there will be something that you will learn about it regarding these markings. So just hold the breath for now, guys, that okay, we could see that it is called a right angle triangle, but these markings mean something. And there are only two sides. Let me just get to number C, then you will see why, what do those markings mean. Then number C, we have what we call an isosceles triangle. Why do we say an isosceles triangle? Remember, when we were busy with vocabulary there, guys, we said an isosceles triangle is a triangle that has got two sides equal. Two sides equal. How do we see that these two sides are equal? Because the markings, again, guys, there is one tick there, there is also one tick there. Is there a tick on the base? No, there is no tick there, which means only two sides are equal. Only two sides are equal. Remember, the third side is not equal to these two sides. Why? Because there is no mark that shows that they are equal. So it means that only two sides are equal. And when there are only two sides equal, we are talking about an isosceles triangle, guys. So let us not forget about that. Now let me get to number B just a bit, guys. Remember we spoke about number B being a right angle triangle. But because it has got these markings, we then call it a right angled isosceles triangle. Why? Because there is a right angle there, there are two sides equal there also. When it says, when these two sides are equal, it means that it's an isosceles angle. But what type of an isosceles triangle? It is a right angled isosceles triangle. Why? Because there's a right angle there and also two sides are equal. Right, let us move to number D. In number D, we have also a right-angled a right-angled isosceles triangle. We look at the markings again. There is a 90 degrees there. Although the line might have not been drawn, but there is a 90 degrees there, which will show that this is a right-angled isosceles triangle. And then number E, let us observe the markings. There are 2 here, there are 3 here, there is 1 here. Meaning, the markings are not equal on each side. Here, there are only 2 markings. Here, there are 3 markings. Here, there is 1 mark, which means these markings are not equal on each side. Now, if these markings are not equal on each side, then we have what we call a scalene triangle. But, guys, let us not forget, our focus, what I want you guys to be very careful of, it is basically triangle A, which is an equilateral triangle. Why? Because the markings on each side of a triangle are equal. Triangle B, which is a right angle triangle. Why right angle? Because there is an angle equal to 90 degrees there marked, and there are 2 markings there. And then triangle C, there are only 2 markings on each side, one side, but there is no marking on the base, which is called, now it is called a isosceles triangle. Right, guys? Now let us get to practice it, do it practically. Let us do the following activity. It says here, use the following triangles to answer the questions that follow. We have triangle A, we have triangle B, and we have triangle C. Remember, I said these very key things that you need to look out for. These very key things that you need to look out for. Now, let us check. Number 8 says, which triangle has only 2 sides that are equal? Now, you will look at them and give me the answer. I will give you guys exactly 3 minutes. Number A again says, what is the type of a triangle called? In other words, the one that has 2 sides equal. B, which triangle has all 3 sides equal? What is this type of a triangle called? C, which triangle has an angle equal to 90 degrees? What is this type of triangle called? Right, guys, your 2 minutes begins now. Let us try, as I've said before, guys, that we need to have our exercise books. Let us try and do this activity as fast as we can. Right, guys, welcome back. Our time is up. Now let us see, guys, there. Number A, guys, let us observe triangle A there. We can see there are markings, ne? Triangle B, there is that small square formed there. And then triangle C, there are 2 markings. Right. First of all, which triangle has only 2 sides that are equal? That is question A is asking us. Which triangle has 2 sides equal? Right. You remember that, guys, we spoke about the most important part there being the markings on the triangle. Ne? Now let us see which triangle let me do this. Right. Then Which triangle has only two sides that are equal? For number A, let us put the answer there, guys. The triangle that has two sides equal is triangle. Let us see. It is triangle. Let us see here. This one has got 3 markings. It cannot be having two sides equal. This one has got only this right angle there. This one has 2 markings. So, which means our answer is triangle. Yes, that is correct. It is triangle C. It is triangle C. Now, the second part of the question says to us, what is this type of triangle called? Remember, we said a triangle that has got 2 sides equal, it is called an a triangle that has got 2 sides equal, it is called an isosceles triangle. It is called an isosceles triangle because it has got only 2 sides that are equal. Right? Now let's see. Number B is asking us, which triangle has all 3 sides equal? Which triangle has all 3 sides equal? Now we check there. 1, 2, 3, 1, 2, 3. We can see this triangle is triangle A. It has got 1, 2, 3 markings. And all these 3 sides are what? Are equal. So, yes, you are very correct, guys. It is triangle A. So, we will put it down, say, it is triangle A. It is triangle A that has got all 3 sides equal. And then what is this type of a triangle called? It is called an equilateral triangle. It is called an equilateral triangle. Remember, number B was asking us which triangle has got 3 sides equal. Which triangle has got 3 sides equal? Now, number C. Number C is asking us which triangle has an angle equal to 90 degrees. There we have our 90 degrees. Therefore, it is triangle B. And then the questions that they ask us, what is this type of a triangle called? Remember, a triangle that has got an angle that is equal to 90 degrees, it is called a right angled triangle. It is called a right-angled triangle. So guys, these are our answers. The first one there, guys, we spoke about a triangle that has got two sides equal. A triangle that has got two sides equal, it is called an isosceles triangle. And then we spoke about a triangle that has got all sides equal. We have seen there, we say it is a triangle, it is triangle A, it is called an equilateral triangle. And then we said the triangle that has got one right angle or an angle that is equal to 90 degrees, it is called a right-angled triangle. So we were able to answer these ones. Right, then let us move on. Now, let us classify the following triangles according to their sides. Let us classify them according to their sides. Here, we have example an isosceles triangle, which is this one. Why is it an isosceles? Remember, guys, we focus on the markings that are given to us there. These two markings represent that this is an isosceles triangle. This is an isosceles triangle. Now, what about number A? Yes. 1, 2. It is also an isosceles triangle. Why? Because it has got two markings. And then number B, we can see there is 1, 2, 3. Now, a triangle that has got 3 markings that are the same in each side, then it is called an yes, correct, equilateral triangle. Equilateral triangle. 3 sides are equal. Let us look at this one, number C. There is a mark here. There are 2 markings there. There are 3 markings there. And there is also a right angle here. Remember when we were explaining under the vocabulary there, if it is like this, it is called a, yes, right angle isosceles triangle. Right angle isosceles triangle. Right, number D, check the markings. 1, 2. They represent that these 2 sides are equal. And if 2 sides are equal in a triangle, then that triangle becomes a isosceles triangle. And then let us check number E. There is a mark here, which is the same as this one, and there is also a right angle there, which equals to 90 degrees. So if it is like this, be careful, it is not the same as this one. Look at the differences. This one was 1 marking, 2 markings there, and 3 markings here. But with this one, there is only 1 and 1 and 90 degrees there. So if it is like this, this is what we call a right, yes, you are very correct there. A right angled triangle. Excellent, yes. That's what you do when you are focused. Thank you very much. Right, guys, this is how we do it. So Can you see there, guys? The markings were playing a very important role for us to be able to describe or classify these angles according to their what? To their sides. Remember they were saying according to their sides. Now we were just focusing on the sides and the markings. The markings were the ones that we were looking into them, saying, okay, here there's one mark, here there is a one marking, and here there is also one marking. And if these markings are all one in the same direction, in the same side, in all the sides, one marking per side, then it means it's an equilateral. Two markings in the side, it means it's an isosceles triangles, because one this side and one this side means that those two sides are equal. It means that, guys, again, if it comes to a push here, they say it's 5 centimeters, for example. And then they ask you, what will be the length of this side? That will be simple, guys. Yes, very good. Because it is 5 centimeters here, it will also be 5 centimeters there. Why? You'd reason say because the sides are equal. Why? Because it's an isosceles triangle. Why? Because in an isosceles triangle, there are only 2 markings per side, and there are only 2 sides equal. Right. All right, guys, let us move on. All right. Classify the following triangles according to their angles. Now, remember, guys, we were classifying them, the first ones, according to their sides. Now we are going to classify them according to their angles. Let me just put this. This is the same question here. We are now here in number 2. We say classify these. We will focus on number A, number B, and number C. Example, they say the right angle triangle, which is this one. It's already sorted for us. All I was to do is to look at A, B, and C. Now, when you look at A, according to the angles, how we will measure, how we will find the angles. The angles will be here on the vertices. Can you see that, guys? So, because the space here, and again, guys, here, this is where your protractor will help you. This is where this mathematical drawing instrument comes handy. Now, in this mathematical instrument, I'm going to take out a protractor. Here's my protractor. Then, with that protractor of mine, what am I going to do? I'm going to measure the angle. Remember, the instruction says here, we classify according to their angles. We classify sides according to their angles. Now, if we classify sides according to their angles, we need to measure them. And we need to be very careful on where we put our protractor. How do we put our protractor? Remember, the base, which is this part, the base here will be this part, here will be this part. It must align to 0. It must be the same as from 0. Now, when you measure this angle, you will see that from, say for example, from, if we want to do, we measure this one anti-clockwise, from here to here we have 20 degrees, which will be here for this one. Let me just write it there because I don't have a space. And also when you measure here, on the vertex you put your center of your protractor, and then you measure the angle here from 0 here. We have 20 because here, remember, this line goes here straight. We have also 20 degrees. Without even going further, guys, we can see two angles are equal. It is 20 degrees this side, it is also 20 degrees this side, meaning that if these two sides are equal, I will do this marking that 1, 2, 1, 2, they are the same. Because why am I not making 1, 1, 1? It will make it as if all these, they've got the same marking. So the markings there will show me that this is not these two sides are not equal to this one. These two are equal to each other. Now, if two angles are equal, then we can classify this as an isosceles triangle. Triangle. Right. This one, it has got a right angle there. So we can see this one is a right, because there is an angle equal to 90 degrees. Is a right angled isosceles. Why we call it an isosceles? It is because, remember, the angle that is going to be here will not be the angle that will be here. It will not be equal to that angle. So if these two angles are not equal, then it is not a right angle triangle. It is a right angle isosceles triangle. And then here, number C. Again, here we can measure using our protractor to find out how much each angle. Just observe here, on my arc, the corner of my triangle there, I'm going to put my protractor to measure the side. In other words, I'm measuring this side. So this is where I'm going to put, everything will start here and then it will go this direction. So I will see that this line is somewhere here, and it is equals to 60 degrees, which means it is this line here. It is this line. So I've seen that it is equals to 60 degrees, then I can write 60 degrees there. That is my angle there. For this one, I'll use this side. I will come this side and put my protractor like that. There is the center of my protractor. There is the center of my protractor. Then I'm counting from clockwise direction, because I'm moving this direction. I can see this, my line was going this direction. So I'm using my outer numbers here. I am also having what? 60 degrees. So here it will also be 60 degrees. And then when I want to use this one, remember the center of my protractor must be there. Center of my protractor must be at the arc of the triangle. Remember, because I put my protractor like this, then when I'm counting, let me just fix everything. Right, then I've got two options here. When I put the center of my protractor must be at the arc of my, not at the arc, at the vertex of my triangle. And from the vertex of my triangle, I can count here up to there. So I can see that this line was going at 60 degrees as well. So we can see now that the angles inside the triangle, they are all equal. Now, if all these angles are equal, we know that we are dealing with an equilateral triangle. Equilateral triangle. That is how we do it. That is how we do it, guys. Right. I'm hoping we are still together, guys. It was a heavy, long work that we have just done there. Now, let us get to the third exercise there, where it says draw the following triangles: a right-angled isosceles triangle. Now, guys, since we have already seen the first one, the right-angled isosceles triangle, remember, now we need to draw it. And when we draw it, guys, what I would advise is that we need to have your ruler ready, your 30 centimeters ruler, and we may start to draw it. Number A, it's a right-angled triangle. It's a right-angled isosceles triangle. It means that I will decide on the line that I'm going to draw. Right, let us say focusing on number A. On number A here, draw my line, maybe from 1 centimeter to 8 centimeters, not from 0 there. Then I will take my protractor, because it's a right-angled triangle. I'm sorry, a right-angled isosceles triangle. Then I will put, because I want my arc to be here. So if I want my arc to be here. So if I want my arc to be there, then I will put the center of my protractor there. Not my arc, by the way, guys. I'm very sorry there. If I want my vertex, one of the vertex to be here, then I'll put my protractor there. Then when I put my protractor there, this is where my vertex will be. Then I will count from 0 here, using the inner number counters. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. 90, I know that in 90 I have my right angle there. Then if I have my right angle, I will draw it there. Then I put the point, my dot there. I put my dot there. Remember, let me just do a demonstration again. I said I will put my protractor here. Where the vertex will be, this is where my center of the protractor will be. Then from 0 here, it will be 10, 20, 30, 40, 50, 60, 70, 80, 90. Then I put my point here. Then I can now join my point. It is up to me whether I get to that point, but I know that it will go this direction. I may not even reach there, because I know that even if I'm not reaching there, but the fact is that from my vertex here, it is a 90 degrees, and I will do my marking here. Remember the topic that we just covered when we were doing geometry of straight line there. That will be our perpendicular lines there. 2 lines crossing at each other. Therefore, I will join my last 2 parts . Now these two last parts here. Then what I must do, guys, remember it is a right angle isosceles. So if it is a right angle isosceles, what do I do? It means that no sides are equal. How do I put that sides are not equal? By the markings. So this one, it is what we call a right angle isosceles triangle. Then let us check number B. What was number B asking us to do? Number B. An equilateral triangle. An equilateral triangle. Let us draw an equilateral triangle. Put my ruler there. It is going now to help me strong. Maybe we may start from 0 centimeters, maybe up to 7 centimeters. What do we know about an equilateral triangle? It means that all sides are equal. Now, if from here, from 0 in my ruler there to 7 centimeters, it must also, from the other sides, also be from 0 to 7. But here, I need to make sure that I measure my angles to be equal also. Now, when I measure my angles to be equal, remember, where I'm going to put a vertex, this is where the center of my protractor will be. Then I will count from 0 here, and I will use the 60 degrees because I've seen that angles in a triangle that is an equilateral, they are 60 degrees each. So my 60 degrees is there. We can see here from 0, 10, 20, 30, 40, 50, 60 is here. Now, if 60 is here, I will also put my vertex here. Where my vertex will be, I will put the center of my protractor. Then I will count with the out numbers, out counters, outside counters. Here it will be 10, 20, 30, 40, 50, 40, 50, 60. This will be where my 60 will be. Therefore, if I've made those two markings, I believe this one will just a bit disturb us. Now I need to make sure, remember guys, from here to here, it was 7 centimeters. Now we need to write it down and point it out. This is 7 centimeters. Meaning it's an equilateral triangle, but I'm seeing the direction that I'm going to take. Because these 2 points, they show me how I'm supposed to put my ruler. But I must be careful here, guys, that it must be 7 centimeters from here, taking this direction towards my point. Here, I will start from 0 because I started from 0 there. Therefore, my 7 centimeter will be somewhere here. Just forgive me for that, guys. It's going to be a bit not nice. But it must go along where my dot was. Can you see there? And also, this one must be 7 centimeters. You can see from here to here, it is 7 centimeters. So I'm going to join it. There it is my equilateral triangle. So therefore, it is 7 centimeters here. It is also 7 centimeters here. Now, I will do also, just for the interest's sake, put the markings just to make sure that I have drawn an equilateral triangle. Then we can just verify it by measuring from here to here. From here, let me just put my ruler this side so that you can see this line. From here to here, it is 7 centimeters. From here to here, it is also 7 centimeters. From here to there, it is also 7 centimeters. Therefore, this is an equilateral triangle. Equilateral triangle. Meaning that all sides are equal, including the angles inside. The angle here, it is going to be 60 degrees. We have done it. The angle there is going to be 60 degrees. The angle here, it is also going to be 60 degrees. Right, guys, number C and number D, an acute angle isosceles triangle. It will be yours to draw. It's going to be your homework. And an obtuse angle triangle, remember, it will also be your homework. Remember that an obtuse angle triangle must be a triangle where one angle must be above 90 degrees. It must be above 90 degrees, but less than 180 degrees. So it must be between 90, just above 90 and to 179. Right, guys? Now, this one, let us focus on this one. Name each type of a triangle below. We've got A. Our A is very important there. We've got 12 millimeters here. We've got these three markings. All three sides, there's a hint there, all three sides are equal. There is 70 millimeters there. Two sides are equal. There is 55 millimeters with the markings there. No sides are equal. That will be for us to do number A, to name the angles. Number B, use the given information to determine the length of the following sides. Now the sides are called like this. This AB is the side. BC is the side. AC is the side. ED is the side, or DE is the side. EF is the side, or FE is the side. FD is the side, or DF is also the side. Here, HG is the side, or GH is also one and the same side. HI is the side, or IH is also a side, which is the same. IG is the side, or GI also a side. Depends on which letter you start with. But normally we go this direction. Now, number B, we use the given information to determine the length of the following sides. Can you determine the length of GH in this one? We'll answer that one. And HI here. And you will need to explain your answer there, guys. That was the part of number 1. Number 2, the square on the corner of a triangle JKL. Remember, this is a triangle JKL. Shows that it is a right angle. Yes, we do agree. This small square shows that this is what we deal with. This is a right angle. Now, is this triangle scalene, isosceles, or equilateral? We'll have to come up with the answer there. Then we need to name two sides of the triangle that are equal. The sides will be the sides will be, if you see that JL is equal to LK, you'll say JL is equal to KL, or JK is equal to KL. Right. What is the length of JK? The length from here to here. And then name two equal angles in this triangle. You'll name two equal angles. What is the size of angle? Remember, guys, this is very important. This is very, very important. J here is just got a sign there on top of it. That sign, it means it is angle J. It is pronounced as angle J and angle L. What is the size of angle J here and angle L here? Right. Let us get to it, guys. Now, let us get to it fast and fast. Number 1A. Name each type of a triangle below. Let us give the names. We've got triangle A. We've got triangle A, B, C is triangle A, B, C is N. Because we have seen the markings there, guys. There's a mark, there are 3 marks. By now we are mastering it. Is N? Yes, very good. Is an equilateral triangle. Triangle D, E, F. Can you see the way I write, guys? This is the short way of saying triangle. So it is triangle DF is triangle DF because there are 2 sides that are equal. They wrote there to us. So an angle that has got 2 sides that are equal, we call it an Well done, well done. It's an isosceles. Sorry, triangle. Isosceles triangle. And then we have triangle GHI is, sorry, is because let us check the sides. There is 1 marking, 2 marking, and 3 markings there. So by virtue it says that there are no sides equal. So is a scalene. Remember a scalene, guys? Yes, it's a scalene triangle. Because why? There are no sides equal. It's a scalene triangle. Because they also shown us that there are no sides equal. Now, number B of this question says to us, use the given information to determine the length of the following sides. AB will be equal to how much? Which is AB? This line from A to B. Remember, guys, all sides of this triangle are equal. So if there is 12 millimeters here, there will also be 12 millimeters there. There will also be 12 millimeters there. There will also be 12 millimeters here. So AB will equal to 12 millimeters. Now BC. BC, which one is BC? BC. Also, how much? Yes, very good, very good. Yes, it's 12 millimeters because it's an equilateral triangle. And then the last one, which is EF. EF, what will be the here? EF. EF. This side is equal to this side. So D is 70 millimeters. Here also will be 70 millimeters. EF will be 70 millimeters. 70 millimeters. These are the correct answers, guys. Right, guys? So here it will be your homework to do, guys. You do this, number 2. This will be your homework. Number C also, can you determine the length of GH and HI? Unfortunately, no. Why? Because there are no sides that are equal here. So for number C there, we have already provided you with the answer there, please. There are no sides equal here, meaning that you cannot be able to determine the length of GH and HI. Just by observing it, you cannot. Right, guys, thank you. Let us move on now to the last part. Here are the tips that are prepared for you guys. Number 1. Before making a decision on the type of a triangle, take a very careful observation of the marks and how many are they in each side. Please, guys, very careful there. Please, before making a decision on the type of a triangle, take a very careful observation of the marks. And when I say the marks, I mean the markings on each of the sides of the triangle. Number 2, always remember that the sum of angles in a triangle always add up to 180 degrees. They may not be more than that in a triangle. Very careful there. And always read the instructions carefully before attempting on answering them. Read. If you don't understand, read it more than once. You may read it twice or 3 times so that you may be able to be very good with your answers. Again, last one. Practice, 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 guys, because without practicing, we'll never master it. So you need to practice and practice and practice. With those words, guys, I thank you. It's been a plum, pleasing pleasure as well as a privilege being with you, grade 7s. Hope you gained something during the presentation. All the best.